welcome back to the lecture series of communication system. In this lecture, I am going to discuss about the angle modulation. So, angle modulation is actually divided into the two parts: frequency modulation and phase modulation. If you combine these two modulations, so it is called the angle modulation. So, basically, angle modulation include both frequency and phase modulation. In frequency modulation, frequency of the carrier is changed with respect to the amplitude of the message signal. And in phase modulation, phase of the carrier is changed with respect to the amplitude of the message signal. So here one thing you must remember that in the frequency modulation, frequency of the carrier will change. So in modulation actually there are the three terms. One is the information signal, one is the carrier signal, and one is the information and one is the modulated signal. One is the modulating signal, that is also called information signal. Second is the carrier signal, and output is called the modulated signal. It means in input we need two signal. Either we call it the modulating or information signal, and second one is called as a carrier signal. And after in output of a modulator we got a modulated output, that is called the modulated signal. So here in the case of the frequency modulation, frequency of the carrier is changed in accordance with the amplitude of the message signal or modulating signal. And in the case of the phase of the carrier is changed with respect to the amplitude of our instantaneous value. Amplitude is also called instantaneous value of the, either we call a message or we call information signal. So unlike the AM, both FM and PM are non-linear. Similarly, I am already discussed about the amplitude modulation. So in amplitude modulation is a linear type of the system, but frequency and phase modulation is non-linear system. So due to this non-linearity, implementation of the FM and PM are difficult in comparison to the AM. So in FM the carrier amplitude remains constant and the carrier frequency is changed by the modulating. See this particular highlighted term here. Frequency of the carrier signal is changed in accordance with the amplitude of the message signal. So if you are talking about the carrier amplitude, it is the constant. If the carrier amplitude will change, then it is called amplitude modulated system. So you see, I think you understand what is the difference between AM, FM and PM. PM is phase modulation, AM amplitude modulation, and FM is a frequency modulation. Then we discuss some of the basic terms. So the first basic term is the modulation index. Here it is represented by beta, and that is beta is equal to delta F upon FM, because here frequency will change. So the modulation index is basically defined in terms of the frequency, and its unit is, it is a unitless quantity, that it is the ratio of the frequency in that case. Similarly, in the case of amplitude modulation, it is a ratio of the amplitude, but here it is a ratio of a frequency. So here it is the delta F upon FM. Delta F is the frequency deviation with respect to the FM, and FM is the modulated signal. Then if you write what is the expression of FM signal, so see here it is the frequency is changed, so it is represented by 2 pi fct plus beta sine 2 pi fcm into t. See here it is a trigonometric function of a function. Here cos omega t, but omega is also a sinusoidal or cosine function. So this type of the function can be dealt by using the Bessel's function, because it is a function of a function. Then the modulation index of a PM signal, that is represented by Kpm is equal to Kp into Em, where Kp is nothing but the phase deviation, that is equal to delta theta upon Em. It means the phase deviation with respect to modulating signal or message signal. So if you see the expression of a PM, it is instead of the beta they use the delta theta, rest all the term are same, and beta and delta theta is just a variation, that why FM and PM signal look like same. If you see the spectrum of FM and CM, we are not able to identify it whether it is the AM and FM. We need a clear cut definition, then we are able to identify the spectrum of AM, FM and PM. So in PM and FM, the frequency deviation is directly proportional to the amplitude of the modulating signal. In PM, maximum amount of leading or lagging phase shift occurs at the peak amplitude of the modulating signal. In PM, the carrier deviation is proportional to both modulating frequency and amplitude. See this particular diagram, frequency deviation here, this is plotted, frequency deviation is plotted with respect to the modulating signal amplitude. So if it is FN and PM, then it is linearly dependent. When the modulating signal amplitude is increasing, frequency deviation is increasing. So A is represent modulating signal amplitude, but modulating signal, if we are seeing about the modulating signal frequency, so in the case of phase modulation, it is linearly dependent. Phase deviation is depends upon the modulating signal frequency, but if it is the FM, then it is the phase modulation signal frequency is constant. So that is the basically difference of FM and PM that can be shown by using this particular graph. And second, this frequency and phase is actually correlated to each other. So if a message signal is first integrated and it is passes to a phase modulator, output a FM signal. Similarly, if a message signal is first differentiated and it passes to a frequency modulator, then output is a FM signal. It means the frequency and phase modulation is correlated with each other. So that's all about the today lecture. In the next lecture, we continue this frequency and phase modulation. Thanks for your time attention.